Welcome to this third session on Focal Framework Metadata Layer. I recommend you to look at the previous sessions to get a more complete understanding. In this session, we will look on how you can use the metadata that we implemented or showed how to implement in the previous sessions and view the physical model as it's logical modeled. The agenda today is to go back and look at the focal logical model. And we're going to look again at the relationship between the logical and the physical. And then we're going to look at the relation between the metadata layer and the data layer. And then we're going to do a quick look on how you can use the metadata layer to access the physical layer in an MS SQL Server implementation. This is the focal logical loan model. It has been expanded somewhat since the previous sessions. Now we are using 4 different descriptor concepts. We are using the CD, which stands for conditions, and CL for classification, SecID, that is secondary ID or business identifiers, and GEARIA X, which is GEARIA or geopolitical areas. Those descriptor concepts are used in this model, and we have 5 different atomic contexts. Area of legal jurisdiction, which shows us under what geographic geopolitical laws the loan is governed. Loan number, the business identification of a loan. Loan amount, how much the bank agreed to lend the customer. Risk category, in what risk category the loan has been assigned to. Loan period, that shows the agreed length of the loan. And rating, what rating, if any, that the loan has. And if you remember, when we looked at the metadata model, we had this extended model, and we have now implemented this full loan focal and all its descriptor concepts and all its atomic contexts and all the attributes into this, and we're going to look at it how we can use it in a physical implementation. But just to remind you how this was done, we had a focal which contained what focals we have been modeling. So in this case we had the loan focal, and then it had a descriptor concept called loan CL, loan classification. And that classification had one atomic context, risk category. And the risk category had an attribute, a logical attribute called the risk category. Now those atomic context and the attribute was mapped into a table pattern column. The risk category attribute has been implemented to store its values in the physical column val string. And this has been done for all these atomic contexts. This is another way to show a mapping. The atomic context loan period has been implemented as such that the loan start date of the atomic context loan period, the loan start date goes into the physical column star timestamp. The loan end date goes into the end timestamp. The loan length into the val string, and the period type into the physical column UOM, the unit of measure. So this is just to show you how the data physically will be loaded into the physical table. Before I show you how the metadata can be used in an SQL solution, let's repeat what I showed you in the previous presentation. So when looking at the physical table in the data layer, they don't make that much sense without the metadata layer. In this case, we are looking at the loan CD table, a loan conditions. We can see that it has an atomic context in it, but to understand it, we need to go into the metadata layer. Normally we have a view written on the metadata layer semantic model where we can do the join and see what this data means that resides in the data layer, how it is described and how it's modeled logically. In this case, we can see that the atomic context loan amount has two logical attributes, the loan amount and loan currency, and they have their respective values stored in the physical columns val string and unit of measure UOM. If we shift and look at the loan CL, we can see how the risk category has been implemented. Since the atomic context key is always part of the descriptor concept tables patterns as a type key, the join to move between the data layer and the semantic model in the metadata layer is always the same. It's a repeatable pattern which is easy to use and often used to create views, functions, and store procedures on the data layer. So when combining the data layer with the metadata layer, you can replace keys and generic physical column names with a logical representation in a fully repeatable pattern. So let's try that out and see how it can look like when doing that. First of all, let's look how this view on the semantic model look like. And we're going to look at one specific atomic context, the loan period. And here you can see that we have a loan focal which has a descriptor concept name, loan CD. And if you remember, the name of the focal and the name of the descriptor concept is the same name we have in the physical implementation of these tables. So in the physical implementation, in the data layer, there resides one table called loan focal and another table called loan CD. And we could see that it had an atomic context called the loan period. That atomic context contained four attributes: the period type, the loan start date, the loan end date, and the loan length. And here you can also see how these has been implemented into the table pattern. The period type goes into the unit of measure. The loan start date is loaded into the start timestamp. The loan end date goes into the end timestamp, and loan length goes into the val string. Now, when using this data in a store procedure, in this case we call it the store procedure for focal logical view, and we decide to look at the loan focal and the loan condition and just one atomic context, the loan period. We can read the data layer and show it as a logical view would do. So in this case, we can see that we have two loans, where one is called 123 and 1321. And here is the loan start date, and here is the loan end date, the length of the loan, and the period type. So you could see that this one has a period of 24 months, and this one will be going, this is a loan that has a period of 48 months. Now, if we would remove and not look at a specific atomic context, we can see all atomic contexts that are within the loan CD table. Remember that the descriptor concept name loan CD is also the representation of the physical table that will be loan CD. So if we look how that has been implemented, we can see that we have two different atomic contexts, the loan amount and the loan period. And we can also see their specific mappings of the attribute, the logical attributes, into the physical realization. And now, if we look at the loan CD, what this store procedure now is unpacking and translating all the data from the physical layer into a logical view of the data. So here we can see that the same loan keys, we only have two in the example, that they also have a loan amount. And we also see that the loan amount has a currency. But we also have the start date, the end date, the loan length, and the period type. Now, if we remove the condition, now we say that we want to see all the descriptor concept that has been implemented for the loan focal and all the atomic contexts that resides in the loan focal. Now we can see it's a pretty big one. We can see that we are using the conditions, we have classifications, we have secondary IDs and geographic area. And we can see that there is all of those atomic contexts that we looked on earlier in the presentation at the logical model has here been implemented as their atomic context, the logical attribute, and how they are mapped into the physical layer. So by doing this, we can now unpack the whole focal. So this is the loan focals, all attributes from all of the different descriptor concepts. Now, this is a really nifty thing. So if we look at the name of this GeoRX, it says area of legal jurisdiction, but it shouldn't be called that. It should be jurisdiction with a D. So we spelled it wrong when entering this into the metadata layer. So let's update that, right? So we set it to jurisdiction instead of jurisdiction, and we execute that. Now, when looking at unpacking the logical view again, we can see that this has changed its name to the correct name, and it's been done without any work on code or needing to change any tables or anything. It's just a metadata change that made us be able to change the name of the logical attribute, which this focal logical view then shows us instead of the physical implementation. Now, since the focal pattern is totally reusable and it follows its pattern all the time, independent of focal, you can use the same store procedure to look at any focal. So let's see here, if we have implemented the customer focal as cust focal, we can see what is implemented. Oh, there's a lot of things implemented on the customer focal. We have a secondary ID, we have some ERIX implementations, electronic address, some classification, and name. And we can see here we have date of birth, country of birth, citizenship F1 and 2, email address, mobile phone number, gender, customer level, official name, and how they have been implemented in the physical tables. So then let's look at it from the logical view on unpacking the customer focal. And there you can see that we have two customers here. Is one male and one female. One has a customer level of VIP, the other is none. They have their email addresses, they have their phone numbers, the country of birth, and one even have citizenship in two different countries, both in Sweden and the United States, and their official names and the date of birth. And this is just an example on how you can use the metadata layer in your access of the data layer. I hope this has been informative. Thank you.